Hello, everyone, and welcome to this Cassandra Community Webinar. Thank you for taking the time today to join us and usher in this festive season. I am delighted to have with me today three fine gentlemen from the Cassandra community. Patrick Mcfadden, he's the Chief Evangelist here at Datastax. Al Toby, an open source mechanic, and I'll have Al explain exactly what that is in just a second, and Matt Stump, a solutions architect here at Datastax. So thank you to those of you who have already submitted questions for us to answer on this webinar. If you would like to go ahead and submit a question, please use the Q&A tab inside of WebEx. Type your question there. We will get through just as many of them as we can in the remaining time. So before we get started, Patrick, why don't we start with you, and you can give us a little bit about your background and also your areas of focus for Cassandra, and then if you could throw it over to Al, and then Al throw it to Matt.
A lot of throwing around, isn't it? I hope you can hear me okay. I'm out in the middle of nowhere right now.
You are coming through loudly and clearly, sir.
That's what you wanted too. Okay, good. Well, so yeah, I'm Patrick Mcfadden. As Al likes to point out, and I always tell him to stop talking about it, but all those data modeling videos that I do, yeah, so that's me. So I'm the Chief Evangelist at Datastax. I'm also a solution architect. I work with customers on a lot of cool stuff, and so I've probably seen most of the big problems, and I'm always surprised if every day I find a new one that's really cool and compelling to solve. So questions about architecture, development, and operations are all on the board for me. Al?
Hi, I'm Al. I am open source mechanic at Datastax. What that means is I mess around with little projects and find little corner cases and things, lines of investigation around Cassandra and storage, things like why are this particular kind of disk very slow, and figure that out and try to share that with the community. I've been doing operations prior to this, operations for about 15 years, so I've seen a heck of a lot of storage and servers and things like that. So those are all fair games questions, including things to do with Cassandra. I spent about 2 years as a developer and administrator.
Hi, my name is Matt Stump. I'm a solutions architect with Datastax. Basically what that means is I help really large customers deploy Cassandra successfully. That can be data modeling, performance tuning, advanced troubleshooting, planning, applications, all that sort of stuff. Previous to joining Datastax, I was a customer for 2 years. I was one of the first customers on Solar and Hadoop. So a lot of experience both within Datastax and actually out in the field using it as a user.
Okay, great. And are you gents buckled in and ready to get started? I'll take your silence as a resounding yes. So last time we did this, I tried to preempt who would tackle the questions. I learned my lesson. So I'll just read the question, and then whoever would like to claim it, you just jump on it. So this one is from Tul Shekar, and he says, hi. First off, the keys are visible if I run a select star from table till compaction occurs for Tombstones. Way to recover, is there a way to recover deleted data in Cassandra? And it seems tedious. Why is this so? Don't we have a simple way to restore Tombstones in Cassandra?
Wow. I think I hear that one quite a bit. I'm sure Matt probably hears it quite a bit as well. Can't you just do an undelete? Is that kind of, do you guys think that's kind of where he's headed with this?
Sounds like it.
Yeah, there are a couple of issues in there, but yeah, that sounds about right.
Yeah. Well, I mean, a tombstone is just a marker, and it's just a matter of, unfortunately, the act of changing a tombstone into something real is just rewriting data, but then you just need to rewrite your data. I haven't seen anyone create something that would go through, say, an SS table and remove a tombstone. That seems pretty dangerous, actually.
Yeah, you probably want to do a trip through SS table dump, but that would be a lot of work.
Yeah.
I guess the problem, the big suggestion, if that's a problem for you in production, is make sure you're running snapshots regularly. They're really cheap and easy, and worst case, you can get back and recover data.
Yeah, you can take a snapshot with every SS table creation, and so if you wanted to, you could just roll back to the previous SS table, and so there'd be a delta of information which you could get from the commit log. That's probably the best you can do without having to hack together a bunch of code.
Yeah, no, I think every time I've heard the question, like, can I undelete a tombstone, and then I delve into what the real problem is, what they're looking for is something that Snapshot does a lot more efficient anyway. So I think that, yeah, undeleting a tombstone is just a really hard way of doing something that you should be doing in the first place.
Okay, great. Thank you very much for that. Next question, it's a two-parter from Simon. So part one, when can we use triggers in production environments? I think that's more a stability question, maybe a Datastax enterprise related area there. And part two, can we use triggers across different virtual data centers? For example, for the insertion of a new user profile into user profile table in virtual data center 1 can trigger an insertion of a new hire event in event table in virtual data center 2.
Oh boy.
Let's tackle the first one. Let's talk a little bit about
data centers.
Yeah,
guys, hold on. Let's tackle the first part of that, which is, is it advisable to use triggers in production environments today, or, should Simon wait maybe until it's a bit more advanced?
So I'll take the first bit. So triggers became available in Cassandra 2.0. Cassandra 2.0 is shipping. There are people using it. We've gone through 3 minor patches so far. So currently 2.0.3 is available. However, Cassandra 2.0 isn't available yet in Datastax Enterprise. So that means the largest accounts, the largest users of Cassandra aren't on 2.0. So take that for what it's worth. Using triggers, how you described, is yes and no. First, you can use a trigger to trigger on a mutation, which then executes a Java class. That Java class can do anything. That could be an insert into another column family. That could be a call out to a external service. It's just Java. As long as you implement the interface, you're good to go. The triggers are executed asynchronously, and they have their own thread pool that's separate from the mutation stage in Cassandra. Now, I think there's a misconception about how data centers work in Cassandra. Data centers, so if you have 2 data centers, 1A and 1B, they both participate in the same ring. And so they both have views of all of the information. And typically, you would have a policy that says, I want 2 replicas of my information in data center A and 2 replicas of my information in data center B. Cassandra just handles that for you. And so if you write to one of the data centers, that will automatically be replicated to the second data center. So you don't have to use triggers to replicate information between data centers, because that's just an inherent property of Cassandra. So I think that's what you were going for, and if not, you can always send a follow-up question and we'll try and answer it.
Because I heard that one as, will the triggers fire or behave differently in different data centers, right? Or will it fire again in the second data center? That's what I thought they were asking.
The answer to that is no.
Right.
See, and I was thinking that it was about moving data from one, like having a staging table or having it propagate from one table to another, which is not like a replication thing. It's funny, here's three things. But then I would just replace the word data center with the word key space, and there you go.
Okay, great. So Patrick has a question here about solid-state disks. And is it recommended to run Cassandra with solid-state disks?
I had this question. What?
All right, absolutely,
yeah,
is the answer.
I'm on the fence on this one. Help me out.
Yes, so absolutely run Cassandra on SSD.
You want to take that?
Yeah, I mean, that's by far where you're going to get it's kind of the smooth and easy path to running Cassandra. If you just don't want to have to deal with I/O issues, Patrick and Matt can probably go on for a very long time about war stories, finding slow SATA disks or RAID subsystems that are much slower than people anticipated. And it causes a lot of problems, whereas most people running on SSDs are pretty happy and only end up tuning when they find things like saturating the SATA bus. So yes, emphatic yes.
Yeah, I hear a lot of people.
Times, I think you know, maybe there's a misperception out there that we need to definitively clear up, and what we're hearing is a resounding yes, absolutely. Solid-state disks are a really good choice with Cassandra.
Yeah, so the only time that I ever hear pushback on SSDs is that people complain about the cost, because SSDs typically cost twice as much. But if you start to delve into it, it's actually much, much cheaper to run SSDs. With SSDs, you can use leveled compaction, which means you can drive your disk utilization up to 90%. So right there, you're almost getting twice the capacity than the equivalent SAS drive or SATA disk. So you're going to recover costs there. Also, the bottleneck in Cassandra is almost always the disk I/O subsystem as soon as you go beyond data per node that exceeds the buffer cache of the OS. So if you use SSDs, you can run with a much smaller Cassandra cluster often, because the bottleneck is in the disk. So it's almost always cheaper in the long run to just use SSDs.
Okay, great. Let's take this next question. Amrit asks, does CQL automatically split a wide row if it is too large?
Well, I just got this question the other day. No. The cells that are inside a partition are what they are. There's no auto partitioning or anything like that. So that's when you really need to consider your data model and how you partition your data from using the primary key. So when you have multiple partition keys, you want to think about how that's going to break down your data and how many cells will be in there. You can use CF histograms to see what the cell count is and get an idea of what's going on there. But once you reach 2 billion, you're at the end of the road. It doesn't automatically split off.
But CQL does help you with, if you do have wide rows, in a case where your data model isn't a problem. With pagination, you can read through those wide rows without having to have Cassandra load those all into memory all at once and pass them over the wire like it used to do. You can actually page over them, 1,000 at a time or something like that.
Okay, thank you. Mikhail, two-parter here. Part 1, driver question. Do you have any plans to upgrade the Java driver to use Netty 4? Netty 3.7, which is currently used, is not especially garbage collector friendly. So I don't know if any of you have insight into Java driver plans. Why don't we take that part first, because that could be quite short.
I haven't heard anything about it. We'd have to go dig into it with the driver people.
Okay, and part 2 here. Why don't counter tables support time to live on rows and columns? And then he says it's a major limitation as he has to do manual housekeeping on those.
It's an artifact of how counters are implemented. So when you mutate a counter column, you just write down the increment. So if I want to increment a counter by 1, or I just write down +1. If I was going to increment it by 3, I'd write down +3. And then the read path actually merges those values when you request it. And so you're merging multiple columns together. So it's difficult to do TTLs for that.
Okay, thank you very much. And Yong is asking, can we generate an incremental backup right before a snapshot in one transaction?
A snapshot is an incremental backup. Because it's
something you have to enable in the YAML file. It's not like a command line tool.
Yeah, I think you're misunderstanding how snapshots work. It's just hard links to SS tables. And so you can essentially have Cassandra create a snapshot, which is just a series of hard links to the SS tables every time an SS table is created. So you're therefore getting an incremental backup. You're not creating a full snapshot of your data with every single snapshot. It's not like you're copying a terabyte or 2 terabytes of information. It's just you're pointing links to your existing information. That's why they are so cheap in Cassandra.
Okay, thank you. Peter asks, what is the process for restoring from a backed up SS table? Is it necessary to shut down an individual server or the entire cluster while copying the files?
That's a little bit complicated. If it's a purely deleted SS table where there's no overlapping data with other tables that are still loaded in the system, I'm pretty sure you can just copy those into the data directories and use node tool refresh, and it will pick them up live. You need to make sure that ideally you get it on the right node in the token, get it in the right part of the token range, but that can be done live. And snapshots and SS tables can be moved around while the system is hot. Since an SS table on disk is an immutable file, it's not recommended you mess around too much in those data directories unless you really understand how everything is laid out and what the different files are. But yeah, an SS table can be loaded online.
And worst case scenario, there is the SS table loader, which you can use to load SS tables from a different machine into a cluster. You can also use that if you're restoring SS tables onto a cluster of a differing size or using a different partitioner than the previous cluster.
Yeah, and the bulk load JMX is one of my favorite tools. You could use using JMX, you can give it a directory name for your SS tables, and it will read all of them and stream them back into the cluster, reorder the data, hash it properly, put it on the right nodes. It's one of my favorite restore techniques for sure.
Okay, thank you very much. So, Patrick, I think you may be pimping your data model talks with this question, but Artem asks, how is Cassandra's data model different from Bigtable and Hbase? That's part 1. Number 2, are supercolumns removed in Cassandra 2.0 or simply not recommended? Part 3, is the following statement precise? Column family is a map of maps. Keys of each map are always sorted. So let's say part 1, because this is probably a long question. How is Cassandra's data model different from Bigtable and Hbase?
Subtly different. I mean, yes, they both share the Bigtable roots, which means that you have one row with lots of columns, and so that's about where things depart. Maybe some smaller subtleties like secondary indexes exist in both systems. The bigger difference, of course, is that Hbase is more of a sequentially ordered row system, so that you can do things like row scans, whereas with Cassandra it's randomized. And there's going to be more of an implementation detail at that point where you have region servers and you can have scanners and filters that are just very different in how you implement Hbase. It's much more complicated in that regard. Now that we've added CQL, pretty much the differences are huge. CQL makes the programming techniques and then DDL for working with Cassandra so much easier, and it makes it look, from a development standpoint, it's just a lot easier. If you look at some of the projects around Hbase, it's about trying to build schema or something that resembles schema, whereas with CQL, you just have it, and it's enforced on the database level. So as we go forward with both systems are diverging quite a bit at this point, and maybe 2 or 3 years ago you could say they were really, really close, but they're starting to diverge quite a bit.
Okay, part 2 on this. Are supercolumns removed in Cassandra 2.0 or simply not recommended?
No, they're not removed, and they're still not recommended. I actually just went through this exercise. So the implementation and the storage engine has changed quite a bit, and where before supercolumns, the biggest issue with supercolumns was that they created this massive deserialization problem where it had to read in the entire supercolumn and into the JVM. I could tell you that I've seen more garbage collection issues with supercolumns than anything else, and that is usually the case where you do a lot of reads on supercolumns and just starts filling up your JVM. That hasn't been completely eliminated. We still need to read in quite a bit of data. So it's not like we fixed it, but we were making it a lot less onerous.
Okay, and part 3 is the following. Sorry, say again? Okay.
Did I cut out?
Part 3, is the following statement precise? Column family is a map of maps. Keys of each map are always sorted.
It's true, it gets a little bit more complicated in CQL 3 because you can have multiple, what is essentially columns that map back to our partition, and the last element of your primary key is going to be the column that is used to determine sort order. So the thrust of the question is generally true. It gets a little bit more complicated with CQL 3.
Okay, great. And let's move on to another question here from Jason. What is the procedure for replacing a seed node?
There is no procedure. Essentially,
another one. Probably in EC2, if you were using one node for your seed node and that you had to replace that instance, you just go through and just use a different node for your seed node. I mean, you can have as many in there as you want, but yeah, just pick another one. Any node in the cluster can be seed.
Yeah, that's probably one of the bigger misconceptions, that the seed node is special. There's nothing special about it. Seed node is just a designation. It's not any kind of thing that you turn it into. like a master node.
Yeah, some people will actually use just, round robin DNS for their seed node, and so it points to a different node every time. It's essentially the first node that's going to be contacted in order to get cluster information when a node joins the ring.
Do you think it's worth just, for those who are unfamiliar with Cassandra's peer-to-peer architecture, maybe just spend a minute on the architecture versus something like a master-slave architecture? Might be helpful for the newbies.
Sure. So in most database technologies, Oracle, MongoDB, MySQL, Redis, most of them out there, they use a master-slave architecture. So all writes have to be performed through a single machine, and then those writes are at some point replicated down to slaves. There's a couple of problems with that. The first is that your write throughput is limited by the write throughput of a single machine, or you have to shard that machine. The other is you're always exposed to the possibility of data loss unless you turn on synchronous replication. So I write a piece of information to the master. The master will acknowledge that write to the client, and the client thinks it's been persisted to disk and that everything's good. Well, if the master were to go down at that point before that piece of information is replicated to the slave, then that piece of information is gone forever. And you don't have a way to determine how much information was lost. It's just gone. So you can't have true durability if you're using master-slave replication and you're doing that replication asynchronously, which is what most database solutions do. So Cassandra took a different tack. We use a ring of machines. Every machine is the same. They are all peers. They participate in the ring equally. And when you perform a write in Cassandra, you specify what consistency level you want that write to have. So if I say I want a replication factor of 3 and I want my write to have quorum, what's going to happen is you're going to go out and you're going to contact any host in the ring. That host will then go out and contact the node that is supposed to have that information if it's not the node that you're currently connected to. It will write the piece of information there. That node will acknowledge it. And then also it'll reach out to another node, the replica node, for that piece of information and write it there as well. Only after both nodes have acknowledged the write will that write be considered successful and be relayed as such to the client. And so you have a guarantee that the information not only exists on one node, but 2 nodes, and so you can tolerate a single node failure. You can go even farther than that, and using quorum consistency level with a multiple data center setup, you can have a guarantee that your data exists not only on 2 machines, but also within 2 data centers. And for some customers that are using, they're storing things like cryptographic keys, this is particularly important because that information can never be recreated, and there's a very large cost, real cost in terms of dollars if that key is lost. So people always seem to are afraid of tunable consistency or eventual consistency, but in reality, Cassandra offers stronger consistency guarantees than most databases out there. That includes Oracle, MySQL, MongoDB, what have you.
Okay, thank you very much. That was a fantastic explanation. Thanks a lot, Matt. Okay, Constantine asks, and actually we forwarded you this question in your inboxes because there's some level of detail, but I think we can probably tackle it at a high level here. So Constantine had a 4-node cluster running Cassandra 1.2. They upgraded to 2.0 and enabled vNodes, but didn't shuffle them. They added 2 new nodes and ran a repair and cleanup on each of the 6 nodes. Now the cluster is unbalanced, and there's some detail about how it's unbalanced. And his question is, how can they rebalance the cluster again?
Well, there is no rebalance operation with vnodes, for one thing, and that is a pending, I think it's a pending JIRA at this point. I think the first problem was enabling vnodes without doing a shuffle, because that means that all that data is still parked in the same place, and by the looks of it, I'm looking at the email now, you can tell that there was some nodes that were added that didn't get all the data, and this is an X1 and D1. So without going into details about what we're looking at here, yeah, you can have imbalances pretty easily with vnodes. It's not impossible at all. So one thing you should know about vnodes is you will not get a perfect balance. You will see variation of 5–7% between the nodes, and that's based on the amount of nodes you have in the system.
And then in the future, if I understood what you were saying there, is when you add vnodes, you should reshuffle?
No, if you upgrade, if you take a cluster and you enable vnodes, you have to run a shuffle after that. That's the step 2. The way we like to do this though now is to add a data center with vnodes in it, bring up that data center, let the data stream into that cluster, and then use that as your new cluster.
Okay, good. Thank you.
Yeah. Al or Matt probably has more probably add to that.
I mean, you could always decommission the node, which would stream the information off and redistribute it, and then just re-add the node. That would also fix the issue.
Okay, thank you. Next question. This one from Sean. For development and testing of Cassandra, what are the minimum server requirements? Is it 3 servers with a replication factor of 2?
No, not at all. I mean, it depends on what you want to do in your development testing environment, but you should be able to run just fine with a single node. You'll adjust your schema, run replication factor of 1. It's not, we don't recommend that in general, but if you have developers that want to run it on their workstations or you have small environments, absolutely you can run a single node. Down to a gigabyte of RAM, people have gone smaller. I mean, your performance isn't going to be stellar, but for non-production uses, that can suffice and save you a lot of resources. I personally have always preferred 3 to 5 nodes for at least staging clusters so that I get somewhat real-world behavior. I want to see the replication system in action in my staging environment, but for development, it doesn't need to be that big.
I'd say the caveat, of course, is don't spin up a test cluster and then expect it. I've seen this too many times where, well, it's not performing very well, or it's not what I expected. You have to balance that out. If you're going to put suboptimal machines or a smaller configuration, it's not a performance environment. It's more of a functional environment.
Okay, great. Ramakrishna, I'm guessing he is working at a banking and financial institution, because he is asking for, is there a banking financial use case for Cassandra for an OLTP type application?
Boy, that's pretty general. Yes. There you go. Like, what kind of application of financial use case?
Ramakrishna, if you go to planetcassandra.org, we have a 5-minute interview there in use case with Blue Mountain Capital Management. They're a hedge fund manager, and they are using Cassandra fairly heavily for their exchange system. So you can go and read up about that, and there are a couple of presentations as well that they've given at meetups. You know, one of the things about banking and financial institutions, while we have many as customers, you know, some of them tend to keep their use cases fairly close to the vest. But you know, we can certainly plug you in with some folks if needs be.
I could say in general, the types of use cases we see in financial institutions are fraud detection, user stream analysis, also mobile applications that need that kind of scaling front end, the mobile front end information, things like customer-facing websites, a lot of that going on. So, I mean, those are generalities. The 5-minute interviews are always going to have more detail, but it's really when you need that velocity of data.
Great. And I'm not sure, but someone has an IM on that sounds like a duck is being stabbed or something. Okay, next question from VJ. If we have different data sets with the same key, say flow_ID, coming in at different time intervals, what is the best way to model the table so that these new columns can be inserted? And are there any performance implications with updates?
In the same, did you parse that, Patrick? Because it sounds like they're appending to the same row in this case.
Yeah,
if we have different data sets with the same key, for example, flow ID, coming in at different time intervals, what's the best way to model the table so that these new columns can be inserted? That's the first part. And are there any performance implications with updates?
Well, this is straight up time series data model, and this has been talked about endlessly too, so that's good. I mean, there's plenty of information about how this works. I mean, essentially what you're looking at is a single storage row, but in CQL it works quite well. You can create a primary key, say with that flow ID, and it looks like, and I've seen this several times where you're modeling actual like flows on the TCP stream or something like that, and there's a NASA did a meetup actually on this very topic. NASA uses it for this very use case, so you might want to look that up. But it works quite well if you use the timestamp as the value in your primary key that creates the partition or the clustering key, and the performance is really good, and that's one of the reasons Cassandra is so good at time series is how it lays out that data in the storage engine. So if you're updating that data, say with a flow ID of X, and you have several events that hit time series, time intervals, it will sort it in memory. It will store it on disk in a sorted format. So when you go to retrieve it, it's a single slice, a single seek. The thing I always mention though is that if you're doing something with a generality like flow ID, think about the size of that storage row that you're going to build. That cluster is going to get much bigger. So the partitioning that you want to try to do is maybe flow ID and a date, like a single day or a week. Find a way to break that down if that's the case. If it's something that's short-lived, that you're only going to get a few thousand events off of, then keep it where it's at. But this is a very typical time series data model technique.
And with the updates, the thing to watch out for is if you're doing updates on old or what we call cold data, you could end up triggering compactions of data that's been cold for a long time, depending on which compaction scheme you're on. But that's the one to watch out for, is if it's not actually the kind of time series where your data settles down and kind of gets stored on disk and doesn't change anymore. If you're still changing all the data all the time, then you might want to look at a slightly different data model.
And Patrick, are there any videos you can think of that maybe cover some details of data modeling?
There's a couple. I'll let Al knows about it more than I do, really.
Well, Patrick Mcfadden has this wonderful series of webinars on data modeling, and I think they're on fire, right?
Yes, there's a data model on fire. Actually, I believe I did time series data modeling in Supermodel. Yeah, some of these names are crazy. Yeah, so I have a paper up too on Planet Cassandra. It is getting started with time series data modeling. That's probably exactly what you want. Just replace weather station ID with flow ID and go forth. You will love it. That's not even a video. Al.
Sounds like it should be.
Yeah, maybe I should do a webinar on that.
I know what VJ will be watching over the holidays.
Netflix? No.
Okay, another question here. Are most use cases that you've seen for Cassandra, okay, do most use cases that you've seen for Cassandra use a few column families or a few dozen of them? Have you seen any applications that require hundreds of column families?
I'm pretty sure Patrick or Matt have seen that before. The most I've seen in production is a couple dozen, and I believe there are some problems you can run into if you get into the hundreds, but it does happen. It's just not recommended, right, Patrick or Matt?
It's the number of column families, but see that's a tuning problem. But each column family has a meg of overhead and slab allocation, which you can turn off. So thinking about memory usage, if you had, say, 1,000 column families in a key space, then you would have, a gig of data sitting there, and that's just an overhead for those. But you can turn that off, and that is a feature as of like 1.2.6 or something.
But in general, that many column families, we start to wonder if the data model needs a little bit of work, right?
Yeah, typically when you see that, somebody's taken an existing data model from a relational database where you have to break out a separate table for every single many-to-one relationship, and they attempt to just shoehorn that into Cassandra. Because the data model is, because the types that you can represent in a Cassandra column are so much richer, and you have wide rows and things like that, typically what you'll see is when you migrate from a relational database to Cassandra, that your overall table count shrinks. So that would be my first inclination, is that somebody hasn't gone through that process, and they're probably doing more queries than they need to be.
Underscore table name, I get a little freaky because it's clear that it was just an export of a relational database. And the next bad thing you'll see is where people take multiple tables of data and then join them in memory, like an application. And that's a clear misfire on the data model. Where I've seen a lot of column families is when you have a lot of indexing that you're building, and that's a cool use case, and dozens of column families. But yeah. I really get sad with Matt's scenario there, where I see people just dumping a relational database in Cassandra and hope for magic unicorns. That's just not the way it works.
Yeah, we hear that over and over again. When you get started with Cassandra, really familiarize yourself with the data model. Think differently up front. Don't think in relational terms. I believe there are some good videos on data modeling that will help there.
They sell themselves, right? Right?
Pennies on the dollar. Okay, next question. This is from, I apologize if this is not how you pronounce your name, but I'm going to go with Shady. And I think, again, this is a little misperception that needs clearing up. So how can Cassandra work with, let's say, Hadoop? They're actually saying Cloudera or Hortonworks. So how does Cassandra work with Hadoop? And then their examples, Cloudera or Hortonworks. Given that Hortonworks uses Hbase, what are the best practices? So maybe here you can talk a little bit about, if you need to do some analysis on your hot data versus, maybe ETLing into an external Hadoop cluster or something like that. Who wants to
there are a lot of it depends around that question. So one of the use cases I've seen personally worked on that was very successful with Cassandra and Hadoop together, it was Cloudera, was where there was a bunch of log files that needed to be processed. So they would process those in Hadoop, and then the aggregates would get written out to Cassandra. That's a really sweet use case of where the two come together nicely, because you just use the CQL client from your MapReduce job to write your results out in the final stages. The other forms, where you want to do things like Pig and Hive over your Cassandra data, it depends, gets even more nuanced. And it depends on what you're trying to do. There's DSC, MapReduce, but there's also the Hive and Pig side, especially from the Cassandra side, is improving a lot, especially in future releases. Patrick, you have more to say on that?
That's pretty much spot on. I mean, if you need to import data from Cassandra into your Hadoop cluster, there's, we've got a bunch of classes that you can use that utilize the streaming protocol to easily and efficiently get data in and out. And if you need to do MapReduce or do analytics over data that's already in Cassandra, well, we have a product we can sell you. It's called Datastax Enterprise, and it works really well. And it does, workload segregation so that your analytics nodes don't take down or impact the performance of your real-time nodes. So yeah, it depends on your use case, but we've got you covered multiple ways.
Okay, thank you very much. A few more questions here to get through. Can you use different versions of Datastax Enterprise on different virtual data centers?
Boy, that's general. No, just don't do it. Make sure you're on the same version on everything. I mean, because Datastax Enterprise version usually corresponds with a version of Cassandra underneath. And for instance, you're not going to mix a 1.1 and a 1.2 cluster together. It's just not going to happen. So it's best really to keep on the same versions. It eliminates any kind of emergent bug issues that could happen, or just you just need to be on the same version. I don't know why you would want to be on different versions.
With one big but though, right, Patrick, which is one of the nicest ways to use that situation is when you're doing upgrades. So if your organization is particularly nervous about upgrades, or maybe you personally are, you can have two data centers with the same data, and you can upgrade one data center. Try to only do this over minor releases, but do that minor upgrade on one data center, and then leave it sit for as long as it takes for you to be comfortable that that release is good, and then you can do the other side. But you definitely shouldn't leave them mixed for more than that a period of time.
Well, in an incremental upgrade, sure, you're going to be stuck in that situation. Leaving it that way for any particular reason, I wouldn't recommend. It's just, but I mean, you're talking about an incremental upgrade, which, yeah, of course, you're going to go from like 3.1 to 3.2, okay, or even 3.22 to 3.33. That, sure, makes sense. And it's not.
What I'm saying specifically, though, this is a particular trick that Cassandra can do that most other databases can't, which is give you that time in production to build confidence in a new release. And that might be a case where we'd say it's okay for a few days or a week, so that you just know you're in a good spot. And I've been in operations long enough. It's something that we've always desired, with everything, operating systems all the way through the databases, to be able to do that. And that's the one place where it's a useful facility. But like Patrick said, in general, don't do it.
Yeah, and it's uptime tool, right? I mean, what was your uptime in Uyala, Al?
Well, on the primary analytics cluster, it was 100% for almost 2 years.
There you go. And were you on the same version for 2 years?
No.
Yeah. See, that's awesome. That's what you want.
Okie dokie. Hey, do you guys remember VJ's question about the data model flow ID time series? You do? Good, because he has a follow-up. We need to generate a lot of top-N reports based on the flow information stored as described above. That is the flow ID data model question. Should we use CQL or Solr for this purpose, as Datastax Enterprise supports both?
It's where do you want to? Yeah, I can do this. So it's where do you want to spend the time to essentially performing the work to get your top end. So with Solr, you're indexing the information as it comes into the system. So you're putting in additional costs on all inserts into the column families that are indexed. So you have to price that in. If you do it on the analytics side, then you're doing the work after the data is in the system, and you're going to have slower response times to those queries. Whereas with Solr, you get immediate response time. So you're doing the same amount of work. It's just whether or not you do it up front and you get immediate responses, or you do it at the back end and you get slower responses. So up to you and what your use case dictates.
Okay, thank you. So it's we got about 9 minutes here. Let's see if we can get through a few more. Malay from my healthcare provider, Blue Cross Blue Shield here. Can you talk about Hbase versus Cassandra? You know, obviously we are Cassandra experts, so you know we have much more insight there. But we can probably talk in some generic terms. Earlier we talked a little bit about the architecture. Who wants to take a crack at Hbase versus Cassandra?
How many of us have run Hbase in production?
I haven't run it in production, but the big ones that kind of stand out in terms of when we evaluated it a couple of times when I was at Uyala, Hbase is incredibly complicated to set up and operate. You have to have Zookeeper, you have to have HDFS, pretty much into all of Hadoop has to be there, and then you have to set up all the components of Hbase on top of it. And there are a lot of knobs to turn and a lot of moving pieces. So the big contrast there is that Cassandra has the nodes are all identical, they're homogeneous. Whereas Hbase has a bunch of other moving pieces to think about when you're trying to figure out what's going on. So from an operational perspective, that's always been really important to me. There are obviously higher level differences I can let the other guys go into. Or not?
Yeah, I mean, the development cycle. You know, I tried using Hbase years ago, and you're right, it is very complex. The development side, and I mentioned earlier, I think that from a Hbase is really, you know, centric around, say, Avro and using that kind of, you know, that kind of interface into Thrift and getting data inside Hbase, but then, and not Thrift, but Avro and using the RPC to get data in and out of Hbase, which is where Cassandra was. But with CQL, we're really putting the developer first, where I don't think Hbase is right now. Hbase is more of a Hadoop first type implementation, and it works well in those environments. But for programmers, I think would probably prefer to use something like CQL. I mean, I think that's where we're headed, and I think that's probably a good reason to consider Cassandra.
Yeah, so like Hbase is more complicated. It's got single points of failure. The cross data center replication isn't as strong. The APIs aren't great. The data model is sort of a pain in the butt, and it's twice as slow. So in my mind, I know I'm employed by Datastax, and so I've, drank in the Kool-Aid, but it's from a development or ops perspective, it's hard to see a clear case where Hbase would win out.
Yeah, and the Facebook example is one that comes up a lot, and we hear it a lot. And what's interesting is when you talk to the people at Facebook, the reason why they stuck with Hbase was because they were, at the time that Cassandra was being kindled, they were just waist deep into Hbase. They had years and years of investment into it. And so that's why that went down, but it's interesting to hear the amount of effort that Facebook has invested in making Hbase serviceable for their needs. And so when you hear people say, oh, well, Facebook uses Hbase, you have to put behind the fact that they have entire teams dedicated to making Hbase work for them. And
that's,
whereas a lot of Cassandra installations, there's just one of you that has it running, and generally that should work.
Okay, thank you very much. And yes, with any questions like that, please bear in mind we are, Cassandra experts first, so we're always going to come at it from that standpoint. But definitely recommend you asking the folks who are more familiar with Hbase as well for their views also. Okay. So here we go, another question. I think we probably have time for two more. Since Pig and Hive have similar capabilities, do you recommend or prefer one over the other to use with Cassandra, and why?
So they're both going to do the same thing. Hive is going to be a little bit more friendly to your BI guys that aren't necessarily coming from programming backgrounds. Pig, it has a DSL, it's a little bit more extensible, and has a little bit more in terms of capabilities and extensibility that a programmer or somebody with light programming experience can tap into. That's the only real difference.
Isn't Pig just a little bit faster? It generates slightly faster code, doesn't it?
I wouldn't know.
I think I've heard that before, but I haven't experienced it.
Yeah, I haven't heard the difference in speed. I think it's the direction of who wants to. I mean, the operations case, there's a lot of people who love Pig for the semantics. And then Hive, of course, looks like SQL, so that's easier to approach if you're coming from that direction. The speed one is I haven't heard too much about.
Okay, couple more quick ones. We're coming to the top of the hour. Is there a REST interface for CQL queries?
No, but it'd be pretty easy to write one.
Yeah. It's something that if you do it, just be very careful, because there are a lot of security implications if developers expose that to the edge networks by accident.
Proceed with caution. Okay, we've got another comparison question here. Let's hit it really quick. Probably going to talk about document-oriented approach, but it is Cassandra versus MongoDB. And before you guys answer, this one is from George. George, if you go out to Planet Cassandra and look at the 5-minute interviews, we have dozens of examples of people migrating from MongoDB to Cassandra, and it is always when they hit either a scale issue where Mongo cannot keep up, or operational complexity, which can get operationally very complex with MongoDB. But anything else to add there, folks?
Well, the big difference is if your data is important to your business, then you shouldn't be using MongoDB. I mean, yes, I work for Datastax, but if you follow the news around MongoDB, especially the recent stuff about Coinbase, the writing on the wall is pretty clear. MongoDB at a certain point is going to turn on you and lose your data. I mean, that's just its track record in the industry. You know, use anything else, actually. If Cassandra is not a good fit for your application, then, you know, I would encourage you to look at Postgres, MySQL, Cassandra, Riak. Any of these are going to be better choices. Yeah,
I mean, especially with document models, I would actually prefer to use Couch over that. I think Couch is much better for document databases.
Yeah, well, Postgres has HStore, which actually a lot of people move from Mongo to. That's a different animal altogether. But,
I mean, trying to bring down the rhetoric just a little bit, you know, Cassandra is going to be as easy to use as Mongo in most cases. I think it's gotten a bad reputation in that regard. Try it out for yourself. You know, play with it. It's easy to do. We can help you with Cassandra's side. The Mongo stuff is easy to set up. Do a bake-off and understand how each one works. And then understand the real implications. Go see what other people are talking about. And you'll see plenty of people talking, and you don't have to listen to us. And evaluate it yourself. Run a load test. Find out what it's going to take.
Great, and with that, thank you very much, gentlemen, for joining us today, answering so many questions. We are off for the holidays. Well, we're not actually, but we are off from webinars until January 23rd. Cassandra, back to basics. In the meantime, I know you all want to get going with your Cassandra training. We offer free online training, Java development with Apache Cassandra, at the link on your screen right now, datastaxacademy.elogiclearning.com. While you are digesting your Christmas dinner and all of that stuff and ushering in the new year, fire up the courses and get certified on Apache Cassandra. Gentlemen, thank you very much. We will see you in the new year.